automobile aerodynamics. We get into more specifically what I'm doing later. So here's my outline. We're going to go over what is aerodynamics, why consider it in automobiles, some technical focuses. I'm going to talk about aerodynamic drag, ways to reduce it, wind tunnel testing and experimentation, which we will all do in lab later on, and the progression of aerodynamics in automobiles. All right, so what's aerodynamics? Aerodynamics is the study of the motion of fluids interacting with a solid object. See by the picture here, you got a solid car, which is the solid object, and there's air coming brushed over it. That's from computer graphics software of a wind tunnel. And you see there it says aerodynamics has been used since World War I. They started building wind tunnels. All right, so why would you consider aerodynamics? First off, reduce drag, which is like the main point. Also increase fuel efficiency, reducing wind noise, preventing lift, which you don't really have to worry about with passenger automobiles like the ones you have on your driveways. Provide stability, and you get sleek designs from it. But I'm going to talk to you about reducing drag and aerodynamic drag in specific. Drag is the force acting opposite to an object's velocity through a medium. So here are the free body diagram down here. Yeah, got a nice car here, and it's going this way, velocity. Drag basically just air resistance resisting the car's motion. So here's the equation of drag. So you got the drag coefficient there, times the velocity squared over 2, times the area, and times the density of the fluid, which would be air. The area is the span times the mean chord, whose menu. It's a little hard to explain. I don't know how many you're going to get because we haven't done it yet in lecture, but when you take an object and send it through a medium, kind of there's like a boundary layer that gets created around the object. The air kind of like gets split, and it's a turbulent layer and a bonded boundary layer, and it kind of takes the area of both into consideration. So the couple types of drag. There's friction drag and interference drag. Friction drag is the drag created from the friction between the car and the fluid molecules. Then there's interference drag, which is basically, I'll go over here to explain it. It's basically drag behind the car. When the car, this is just a race car, for example, but when the car is at high speeds, there's a bunch of, as it shoots through the air, there's a bunch of unchanged air in the back that's mixing with the air that was going over the car, so it creates a bunch of turbulence. You can see that on jet engines and stuff. If they take colored smoke, it actually creates a vortex, and it's a pretty neat effect. Ways to reduce it: reduce drag, obviously reduce the drag coefficient, reducing the area of the car, lowering the suspension, the material of the car. Obviously, if you have, I don't even know, but if you have a bunch of unsmooth, rusty car, it's gonna have a lot more friction with the air. You can streamline, and you can remove parts of the car, which is pretty much not safe, but theoretically speaking, that would reduce your drag. All right, so you can streamline your car, which basically, back in like the 70s and 80s, they've been trying to streamline cars. They look really ridiculous, but I mean, they're not really practical either. But you see race cars here, they streamline too. They're all streamline shaped. It moves the point of separation back as far as possible from the car. Point of separation would be right around here. This is where the wing kind of like comes back around the car. Streamlining it pushes that far back as possible, whereas you have like a regular square right here, it'd be right here, since this would not be rounded off. So the air would start to go really turbulent around in the front of the object. Also, you can lower your car, as the automotive industry calls it, slamming it. You see a nice Volvo there, slammed to the ground. It's not aerodynamic because it's a Volvo, but you can also lower your car to the ground, cut the springs, makes it lower to the ground so air can't go underneath the car. Then there's also wind tunnel testing. That's used all over the automotive industry. Experimentally, you have software in there with high-tech air tunnels, and they just put their computer graphics, throw a car in there, and they can measure the amount of airflow around that car. Furthermore, on wind tunnel testing, you see here on the right, This is the second time I've shown this. This is a chart from the book that shows the amount of the coefficient of drag on different cars as they've gone through in history. As you see, like 1920 Roadster would be 0.8. So the drag basically goes from 0 to 1. And the more closer you get to 1, the more drag is affected and the slower the car goes. So you hear trailer trucks around 0.5. And nice coupe would be around 0.28. And here's some progression of automobiles in terms of race cars. I picked race cars basically because it's a little more easier to see the progression in terms of actual street cars. So yeah, here they get more streamlined as they go along, and they can find ways of curving the air around the sides of the car and have these ducts that send air through. And these designs get pushed over on the street cars as well. And here's some conclusions. Pretty much drags the force acting opposite to the object's motion. There's friction interference drag. Wind tunnels are used to experimentally reduce the drag. And that's about it. Any questions?